What exactly is an IPv6 tunnel broker and how do you configure it? You've come to the right place. Let's begin. Our objective for you and I in this micronugget is simple. We want to identify what are the benefits of a tunnel broker and using one, and then we'll take a look at configuring and verifying that it's working. To start off, we have a problem, and that problem is this. A company has a beautiful block of IPv6 address space. I mean, it's great. It's wonderful. They got it from a registry. It's assigned to the company. However, they are isolated from the rest of the IPv6 internet by a service provider who's only supporting IP version 4. So how in the world can we join this network to the rest of the internet? And the answer is, dun, 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 a tunnel broker. Now, a tunnel broker is somebody who's willing to provide one end of a tunnel for you so you can connect. So a tunnel normally has two ends. We have a local end, and at the very far at the light at the end of the tunnel down there, we have the remote end. And in this tunnel, we're simply going to connect logically between two globally reachable IP version 4 addresses as the source and destination of the tunnel. The logical tunnel interface itself will have IPv6 addresses, and with some static routes on our side, we can go ahead and train this router to go ahead and forward traffic for any IPv6 that's not local in this block space out this tunnel interface. To make this all possible, we get a tunnel broker service. I personally like Hurricane Electric. They're fantastic. They're going to give us the IP addresses to use, and if we want, we can even get a block, a /48 from them that we can use internally as well. The internal network is already configured. What I'd like to walk you through is the configuration of this logical tunnel interface, a static route that says to reach the rest of the IPv6 world, use that tunnel interface, and then we'll verify it's working by bringing up a client on this network and have him reach out to a live internet resource. Regarding the configuration, everything on R1 over here has already been done. Our focus is going to be on this logical tunnel interface and the static route that sends traffic out of that tunnel interface. So we'll make a little road trip into global configuration and we'll create out of thin air interface tunnel 5. And I'm going to tell it to be shut down just for a little bit because I want to configure everything and then we'll bring it up. Some of the things they're going to configure besides the description to thank Hurricane Electric for being a tunnel broker for this demo is we're also going to specify the IPv6 address on this logical interface. Now, what IPv6 address are we going to use? The one that was assigned by the tunnel broker. So we've got ::2 on that network, and they've got ::1, which were detailed to me, and that's why I'm using that address. Next, we've got to specify both ends of the tunnel, two IP version 4 addresses. Now, on my gig 1/0, my outside interface, I'm going to go ahead and specify that that's my source, and it does have a global IP version 4 address. And then I'm going to specify as the far end of the tunnel, the IP version 4 address of the tunnel broker, and that's Hurricane Electric's side of the house. By default, this tunnel interface is going to try to use generic routing encapsulation, GRE, but I don't want to use that. You know why? Because the other end of this tunnel, the tunnel broker, is using IPv6 and IP, so it's using protocol 41 instead of the GRE 47. So I'm going to tell this tunnel that it should use the same encapsulation that the tunnel broker is using at the other side. And with all the details for the interface, now we can go ahead and do a no shutdown and then exit out of interface configuration mode. So a couple problems that we have. Number one, we've got this beautiful tunnel interface, but my router really doesn't want to use it because it thinks it's only connected to one network. What about the rest of the internet? To get to the rest of the internet, we would need some type of a default route. We can put one in statically and simply tell this router, hey, if you need to get to anything that you don't have a more specific route of in your routing table for IPv6, go ahead and use the Tunnel 5 interface as an egress interface to reach the rest of the world. So we'll simply add our default route, IPv6 route, ::/0, which means 128 zeros /0 for the prefix length. Go ahead and use Tunnel 5. We can do that because a tunnel interface is a point-to-point network. Whatever we send out this interface is going to end up at the far side of the tunnel. Now, to test this, we can do some baby steps. Number one, let's just verify from a basic IP version 4 perspective that we can ping the far side of the tunnel, which is the tunnel broker's end. And if that works, which is a great sign, let's then see if we can ping the IPv6 address of the far side of the tunnel. So we'll do a ping of the far side of the tunnel. I'm also going to source this from my gig 2/0 interface. That's the interface on the left. And if the ping comes back, which is great, and it did, that also implies that they also know how to route back to my subnet block that they have assigned to me. To verify the end-to-end connectivity, let's bring up a client. I'm going to bring up a Windows 8 client right here. He's going to do stateless address automatic configuration. He's also going to get DNS information through stateless DHCP that I have running on my R1 server. And once he has all that, he should be able to go out to Google or anybody else who has IPv6 services available. Just for fun, let's do a debug of IPv6 neighbor discovery on R1. That'll help us confirm that this client really is going through R1. And this interface at the moment on the Windows box is shut down, but we'll bring it back up. So we'll enable it. There should be a little flurry of router solicitations and neighbor solicitations and respective advertisements. But the goal is to get this guy on the network. So let's go ahead and do an ipconfig again, /all, and let's take a look at the output. He has learned a DNS server, that's fantastic, and he also has an address on the 2001.470.f1a0.1 subnet. And he actually has two addresses. He's got an anonymous one for the privacy extensions, and then he has the permanent one as well. So he should be able to go out. He's got DNS. As long as routing is okay on R1, we should be good to go. Let's bring up a browser real quick, and let's just go to a website such as Google. That should work. And there we go. And if we want to do a Google search for IPv6 test, and let's go ahead and test one. Let's do this right here, IPv6 test, assuming that they're supporting IPv6. And this also confirms the address that we have on this Windows box. So that, my friends, is the benefit of a tunnel broker, to allow your IPv6 network to go across an intermediate IP version 4 network to reach the rest of the internet. In this micronugget, we've taken a look at the benefit of using a tunnel broker, how to configure the tunnel interface, and to verify that it's working. I hope this information has been informative for you, and I'd like to thank you for viewing.